My name is Amy Christosic, and I'm an Inside Health Data Fellow. Today I'll be presenting my web map called Trash Finder. This uses computer vision and satellite imagery to optimize recycling centers. We live in a throwaway society. On the right, you can see a picture of a family celebrating this fact in Life magazine in 1955, when these products were first introduced to the market. This has led to an increase in plastic production, leading up to over 400 million tons of plastic products being produced. This leads to a vicious cycle where informal dump sites are an ecological and health problem. These informal dump sites represent a signal of a failing system. As you can see here on the right, an informal dump site is being burned in the absence of a better alternative to handle the solid waste. We know that over 600 million tons of solid waste are openly burned annually, and this has an impact on our ecological health and air quality. Poor air quality is also responsible for over 5 million deaths annually. Fortunately, this is also a business opportunity. Solid waste could be diverted as a commodity for industrial manufacturing to produce a profit. My application, Trash Finder, aims to solve this problem by identifying informal dump sites. Switching over to the web app that I created in Google Earth Engine using the code editor in JavaScript, you can see here the satellite view imagery. And we can also choose to zoom to a region to view the prediction. Here I've zoomed to the Bay Area, and you can zoom in and out and move the view around. The legend here on the bottom left-hand corner tells us that the blue represents smooth predictions of dump sites. If you click on one of these areas, you can see the value of the prediction in terms of probability. Here we can see that the probability that that location is a dump site is over 70%. We can also choose to view dump sites around the world. Here we're zooming around. You can tell that there's this characteristic burnt out look to these different dump sites as you zoom around the world. And you can see that they're often surrounded by even urban areas or agricultural areas. Fortunately, these images give us an idea of these characteristics, and this is an optimal case for computer vision to quantify and categorize these different images. In order to solve this problem, I created a solution pipeline. The first step was to obtain this data and label it. And so I achieved this by web scraping known geopoints from an open source consortium called Waste Atlas. Once I had these coordinates, I was able to visit these satellite imageries using Google Earth Engine and visually inspect and confirm that these were in fact informal dump sites and create a labeled data set of yes or no. Once these data were labeled, they were ready to be fed to a deep learning model that I built using Keras and TensorFlow and Keras, and I implemented on Google Cloud Platform. Once I tested and validated the models, I then was able to visualize the results of these predictions using Google Earth Engine as I showed. This was an iterative process, and I'll show two of the models that I tried. The first model was a pixel-based model using the Landsat 8 imagery. This means that for each coordinate that I identified as an informal dump site, I extracted the bands or values behind that pixel in each image and passed those band values to a Keras sequential model with 3 layers. This was a very simple model, and we achieved 80% accuracy, but only 20% precision, meaning that we were predicting many false positives. In the second model, I used object identification from mosaic images that I fed to a transfer learning model that was trained on images called VGG16. By removing the top layer of this model, I was able to replace the input with my curated screenshots of informal dump sites. And by removing the bottom 2 layers, I was able to replace the classifier with my binary classifier informal versus not informal dump sites. This achieved an accuracy of 81% and a loss of 43%. The deliverable from this project is being able to quickly identify images as informal dump sites. The ability to scale this prediction model to a planetary scale using high-resolution satellite imagery. One use case is to make a targeted regional investment. For example, the manufacturing facility shown here on the right uses plastic solid waste as input to produce petrol alternatives, but this requires an economy of scale of over 30 tons of trash per month. In order to make this business profitable, the owners of this manufacturing facility would be able to identify informal dump sites in the region and optimize the location of this recycling center. A little bit about me. Again, my name is Amy, and I'm an epidemiologist. I spend a lot of time in the community to understand environmental health risks, and I enjoy using technology to scale solutions to planetary health problems.